So welcome to my lecture series. So in this video we will discuss about case study on Young's modulus. So the Young's modulus is the fundamental property of materials, so that quantifies that the stiffness and the ability to resist a deformation under the tensile or compressive stress. So it is a measure of elasticity, as defined as the ratio of stress to strain within the elastic limit of a material. So this modulus is a crucial in engineering, construction, and material science. So as it helps in selecting materials for structures, vehicles, and medical implants. So for intents in the aerospace industry, aluminum alloys are preferred over steel due to their lower Young's modulus, so allowing flexibility while maintaining strength. So in contrast, materials like carbon fiber composites with a higher Young's modulus so are used for applications requiring rigidity. So a real world example of the constructions of bridges where steel cables with a high Young's modulus provide necessary tension support. So understanding Young's modulus ensures optimal material selection, so leading to safer and more efficient designs. So in this case highlights the importance of Young's modulus in material selection. By understanding the elasticity, engineers can design safer and more efficient structures, preventing excuse, deformation, and potential failures. So my students give a detailed about case study and Young's modulus. Thank you.
Today we will be discussing the applications of Young's modulus. The objectives are to understand the concept of Young's modulus and its significance in material science, to explore various real-world applications of Young's modulus in engineering, constructions, biomechanics, and aerospace industries, to discuss how elastic properties of materials influence their selection in different fields. Introduction to Young's modulus. What is Young's modulus? Young's modulus is also known as modulus of elasticity. It is a fundamental mechanical property that describes how a material deforms under applied stress. It quantifies the stiffness of a material and determines how much it will stretch or compress under a given force. Formula: Young's modulus is equal to stress by strain.
Let us discuss the applications of Young's modulus. Application of Young's modulus in engineering and construction applications. There are two types of applications in engineering and construction applications. One is structural design and civil engineering, and another is mechanical engineering. So in structural design and civil engineering, it is used for selecting the materials for respective buildings, bridges, and skyscrapers. Concrete has a high Young's modulus compared to other, making it suitable and load-bearing material for structures. And steel beams are chosen for their high strength and stiffness, ensuring that buildings can withstand higher stress and strain. In mechanical engineering, it is essential for designing machinery and automotive components like actives and gears and axles. It determines the durability of suspension system in vehicles, and it is used in railway tracks where high stiffness is needed to prevent excessive deformation. Start.
Now let's discuss about biochemicals and mechanical applications. In that we have two types, the bone and joint mechanics and sport equipment. Now we are going to discuss about biomechanics and medical applications. In that we have two types, bones and joint mechanics, sports equipment. In bone and joints mechanics, human bones have a specific Young's modulus influencing prosthetic and implant design. Titanium and stainless steel with Young's modulus values similar to bone are used for hip and knee replacements. Sports equipment used in designing tennis racks, golf clubs, and running shoes for a better shocks absorption and performance. Carbon fiber is preferred in high performance equipments due to its high Young's modulus and low weight.
Now, Young's modulus application in aerospace and material science applications. So under this we have two applications: aircraft, spacecraft design. Another is nanotechnology and advanced material. Firstly, aircraft and spacecraft design. Aluminium alloys and composites are selected for aircraft frames to ensure strength and lightness. Spacecraft components use titanium and advanced polymers for their highest modulus to weight ratio. Secondly, in nanotechnology and advanced material, carbon nanotubes and graphene have exponentially high Young's modulus values, making them ideal for next generation electronics and materials.
Let me give you guys an overview about the Young's modulus. Briefly, let us discuss what is Young's modulus exactly. So, simply put, it's a measure of how much stress is required to produce a certain amount of strain on a material. Stress is typically represented by the symbol E and it's applied to a material while strain is resulting deformation. Young's modulus itself is represented by the symbol E and is measured in units or Pascal or gigapascals. Let us now discuss about formula and calculation. Formula and calculation of Young's modulus is E is equal to sigma by E, where sigma is the stress and E is the strain. To calculate Young's modulus, you need to know the stress and strain values of a given material. These values are obtained through experimental methods such as tensile learning. Now let's discuss about factors that affect Young's modulus. Several factors can affect Young's modulus, including material composition, temperature and crystal structure. Different materials have different Young's modulus values and temperature changes also can impact the modulus value. Additionally, the crystal structure of a material can influence its Young's modulus. Now, we can discuss about the application of Young's modulus. So, Young's modulus is very important because it has numerous applications in various fields of science and engineering. For instance, Young's modulus is used for material selection, structural analysis and material testing. By knowing the Young's modulus value of a material, engineers can design and develop materials with specific properties for various applications. Last but not the least, let's discuss about the examples and case study of this Young's modulus. So when you take an example of Young's modulus values of different materials, we get to know that it has different values. For instance, the Young's modulus value of 200 to 210 GPa is aluminium, which also has value around 70 to 80 GPa, while copper has a value of 110 to 120 GPa.